On this video lecture, I am going to show you analog value programming on PLC. When we talk about process industry, most of the control unit process deal with analog values. Taking some actual example in industry, a heat exchanger process, normally monitoring temperature for a medium. This kind of medium in heat exchanger could be a liquid or even gas. For this medium, either liquid or gas, measuring the temperature is measuring the range between the cooler side of the temperature up to the hotter or the boiling temperature. If we assume that we are using water for the heat exchanger, for example, the temperature for water is ranging from 0 degrees Celsius, which is on the cooler side, up to 100 degrees Celsius, which is on the hotter or the boiling temperature. The second one is the gas flow in a pipe. Okay, for gas flow, most of the time we are interested in measuring the volumetric flow rate or mass flow rate. The third one is pressure measurement in a pressure vessel, for example. So most of the time, the measurement is focused on the measuring pressure. And the fourth example in industry is liquid level in a tank, and the measurement focus is more towards the measuring liquid level in that particular tank. So this measurement could range from the tank empty, could be 0 millimeter, up to the maximum capacity of the tank, could be, for example, 1000 millimeter in terms of level. So this is 4 common physical quantities. The first one is temperature, then we have flow, pressure, and liquid. Okay. These are 4 common physical quantities in process control industry, and these physical quantities are measured in range, which represent most of the time represented by analog values. The measurement of this value are done by a device called transmitter. In this example, you can see here, this is a basic example of liquid level. So we have a level transmitter installed at the tank. Okay. So the focus of this sub-lesson is to explore the analog value processing capability of PLC. All PLC from any manufacturer is designed to regulate a real-time process. Okay, this real-time process, which can be discrete or analog, whereby discrete is always digital form, and analog we always deal with range of values. We look some example. For digital variable or discrete variable, a sorting machine with a conveyor belt. So assume that we have a conveyor belt that function to sort a certain materials. So we install a capacitive or inductive sensor. So when this sensor detect a metal and non-metal material, it will be able to sort. For example, the metal parts will go to first line, and non-metal part will go to the second line. Next, we have a capacitive sensor as a level detection for tank level control. Okay, so assume that this is a capacitive sensor which only detect the level low and the level high of the level tank. Okay, only 2 state is monitored. Only 2 state is observed, whether it is low or high. Okay, this example is one of the popular example for discrete variable. Next, we look on the analog variable, a pressure sensor as a controller feedback to regulate control valve on a pressure vessel. So assume that we have a pressure vessel. So this is a pressure vessel in terms of tank. Assume that we feed compressed air into this tank, so the pressure inside the tank will build up, pressure build up inside the tank. So the pressure is monitored by the pressure transmitter, then the pressure transmitter will send information to pressure controller, and the pressure controller will regulate or will send the information, will manipulate the variable, the control variable, to regulate the control valve. So this one is called as a pressure control valve. A temperature sensor as a controller feedback to regulate the control valve on heat exchanger process. So again, we have assume that we have a heat exchanger. So we should have a temperature sensor, or more accurately, we should have a temperature transmitter as the controller feedback to regulate the control valve on heat exchanger process. Or even we can have both, which is we can have discrete variable and analog variable for a particular process. A pressure sensor as a controller feedback to on off solenoid valve on heating element. So on off solenoid valve is the digital variable. Okay. So far, I have shown you that measurement of analog value is done by transmitter, okay, whereby the definition of transmitter is basically a sensors that come with complete with a transducer. So in process control industry, we always address as a transmitter. In terms of PLC, this transmitter need to be connected to analog signal module of PLC. So now the question is, what is signal module? Okay, what is signal module? A signal module is an electronic device which is also called PLC I/O card. This PLC I/O card need to be installed at PLC CPU. So most of the time, especially for Siemens PLC configuration, we install the PLC I/O card or PLC signal module next to CPU side by side. A common configuration for PLC may comes with several signal modules. So in this figure, it shows that common configuration of PLC may come with several signal module. For example, now we have, in this figure, we have PLC CPU, then we have signal module SM for digital input, SM for digital output, signal module for analog input, signal module for analog output. So for discrete operation, we have a specific signal module for discrete operation. Here we have digital input module 24 volt DC or 120 to 230 VAC. For digital output, we have 24 volt DC or relay type digital output. On the other hand, for analog input module, so for analog operation, we have analog input module. So analog input module is connected to a transmitter. So it is wired to the transmitter. So depending on the transmitter type, if the transmitter measuring voltage, so we should have the voltage type signal module. The most popular transmitter is measuring current. So we can have current signal module, current type signal module. Okay, we can also have resistant and thermocouple. So resistant and thermocouple, most of the time for resistant and thermocouple, it associated with measuring temperature. Okay, so analog signal module is connected to transmitter. Okay, finally we have analog output modules, which provide signal in terms of voltage or current. So these analog output modules is connected to output field devices such as control valve, heater, solid state relay, and etc.